All right, we will get started as a few more people will trickle in. Welcome, everyone, to the webinar, Transformative Shift in Industrial Automation, How Advanced Manufacturing Teams Are Leading the DIY Revolution. Now, let me give you a quick introduction to our speaker, Etienne Lacroix, founder and CEO of Vention. From the young age of 11, Etienne was building full-size prototype planes in his own backyard. It became evident early on that his trajectory would direct him towards the realm of engineering. Following his academic pursuit in the field, he started his professional career joining the ranks at GE. There, he contributed significantly to the product development for plants spanning Mexico, United States, and Canada. Pursuing his passion for product development and integrating his experience at GE, Etienne saw an opportunity to make industrial automation accessible for all manufacturers, which led him to found Vention in 2016 and growing the company to over 300 employees serving over 4,000 manufacturers. Now, just a few housekeeping notes before we start. We will be answering some questions at the end of the session, but feel free to write your questions in the Q&A section during the session, and we will address them at the end of the session. You can also write them in the chat if you want them publicly available for everyone to see, and we will do our best to answer all of your questions with the time we have. Keep in mind that we might have to follow up with some of you via email to get your question answered. So without further ado, I will leave the mic to Etienne, who is coming to us live from the Vention Experience Center. Off to you, Etienne.
Thank you, Sophie, and thanks everybody to join us this morning. What a year we had in 2023, and when Sophie proposed me to wrap up the year with a webinar on do-it-yourself automation, I was quite excited because that's a topic that is dear to my heart. Vention's mission has always been to democratize industrial automation, upskilling the manufacturing workforce along the way. And this is a topic we've been working on for the last 7 years. And I'm quite excited to share today some of the insight that we've learned and navigating that trend over the last few years. Today, I'm in the Vention Experience Center in Montreal. We also have one in Berlin. We had the privilege this year to have around 400 people from both Montreal and Berlin that visit us in the Experience Centers to perhaps participate in demos, do some training, test some use cases as well. So if you had not had a chance yet to visit us here, you're always welcome to do so. I'm quite excited about today's topic, and we have a pack agenda. I'm going to try to keep a very brief note on what is Vention and give you the one-on-one. I'll try to keep that very, very quick. And then we'll mostly talk about the state of automations in North America. We'll talk about the thesis and why we decided to do that research on do-it-yourself automation. I'll share the insight from the report, and I'll bring them some client example as well around how some of the clients we've been working with over the years have embraced that trend and delivered some successful projects. So let's get going. For those that have been following us for a few years, Vention's mission or vision is to build another industrial giant, but we're trying to do that in a digital way, where the experience starts in the cloud and ends in the cloud, bringing along the way tremendous amount of workflow integration, making the user experience very, very simple. And we've been pursuing that mission consistently since 2016. When we translate that into our day-to-day mission, we like to talk about building this self-serve platform that automates factory with confidence. Confidence is very, very important for us because it means that whatever happened in the cloud will translate one-to-one on the shop floor. They'll have the same machine behavior, the same cycle time, the same performance as you would have de-risked this this equipment that robot cells or automated equipment in the cloud. So that's really how we see the world at Vention, and that's the mission we've been pursuing. To give you a sense of where we're at in our journey, right now we have around 18,000 machines in the field. Some of them are very simple. Some of them are amazingly complex, and they've been done with all of you today. I was looking at the people that we have on the line with us today, and they come from the automotive industries, the electronic industries, the robotic field, the medical devices, and some of our partners as well. It's a very wide set of manufacturing industries that have made those 18,000 machines. I think so far we have around 4,000 robot cells that are now in the field operating. And every month, it's around 5,000 engineers that are coming to Vention to design their Nest project and eventually deploy it on their factory floor. So we're obviously quite proud of the traction we got over the years, proving that we're solving a real problems of making industrial automation very simple and accessible for a wider range of manufacturer. Um, in a very quick word, Vention has built this very integrated workflow when one can, think about a machine in the morning and deploy it almost the following day or in the following afternoon. I'll drive you through what a user's joining Vention usually go through, but he usually starts his journey by signing up on the Vention platform to design a new robot cells, a new automated equipment, or even a structural equipment. In this environment, those users have access around 2,000 Lego parts, industrial Lego parts, and all those parts have meant to go with one another. I like to say that if they're available, they are compatible. And because we have both access to the geometric data and the metadata of all of those Lego parts, industrial Lego parts, we can do a beautiful amount of software automation. So we can give our client real-time prices, real-time assembly time. We can recommend the next best part. We can do automatic design validation. We can generate the bill of material automatically. We can compute all the fasteners automatically. So a lot of infrastructure that make the act of design very, very simple versus using a traditional CAD. When our users reach a successful design point, they can start to automate those machines, whether it's in a code-free environment or in a more powerful programmatic environment using Python. And today in this environment, users can both program robot arm, actuator, pneumatic system, and so on. When the machine has been programmed and simulated, we have an idea of cycle time, we have an idea of cost, we have all the elements necessary to do a proper business case and ROI on that potential automation project. Client can move on and obviously order. That's where we operate two distribution center, one in Montreal and one in Berlin, Germany, where we pick, pack, and ship those orders for our client. But the journey is not done. We like to see the client journey being successful only when the machine is now operating on the factory floor. And we have a piece of infrastructure called Machine Cloud to help with deployment of those machines. Think of this as the wizard that guide the users through assembling mechanically their machine, wiring all the sensors and connectors, loading the software from the cloud to the factory floor on the machine, and obviously booting the machine and start operating it. So we have the deploy stage here that is also done with software assistance throughout. And last but not least is the operating stage, where an operator usually will have to, operate that machine on a daily basis. And we want to make sure we can provide the proper insight around the machine operation, which is the machine health, the machine performance, but also providing help. For example, we have a feature called remote support. Think of this as telemedicine, but for machine, where operator at any time of the day can click a single button and be connected with a customer success representative that has full contextual awareness of the machine being operated by the operator, whether it's the digital twin, whether it's the firmware version, whether it's the application version. We have access to all of this to render support in minutes. So that's part of, for us, of our operate pillar. So we have those 5 pillars that we've assembled over the years, providing this very unique user experience where everything's happening in the same environment, bringing tremendous amount of simplicity and speed along the way. So that is Vention. That is the mission we've been on to for the last few years. And before I move to the next section, before I move to the report itself, I want to share a little bit how we understand the state of industrial automation in North America as a whole. When I started my career as a young system integrator, even before my General Electric years, I thought the manufacturing floor were like the world on the left, where everything was automated with robots everywhere. And perhaps, obviously, this view of the world is true, but that is for high throughput manufacturers. And there's tremendously powerful solution that already exists to serve those clients well. I think where the market for us was underserved is on the right side of the screen, where the reality is most manufacturers today are higher mix and still are mostly have little to no automation. And the reason most manufacturers today have little to no automation is because it is not profitable for them to automate with today's technology. It is simply too costly if you're not producing a certain volumes of good on an annual basis. And that's really the folks we're trying to serve here, folks that were currently being underserved with current technology. You take a map of the US and we see all those manufacturing sites, and the reality is most of them, the very vast majority of those manufacturing sites, are high mix manufacturers or in small medium business with less than 100 employees. So the economic of those businesses are quite different. Client contract perhaps is not as long. Some of those manufacturers have client contract that lasts only 3 months or 6 months, sometime a year. And when you're in those economics, you cannot afford a payback that is as long as what a high throughput manufacturers with long client contract can envision to do. And to me, that was amazing potential we saw when we started Vention in the early days, is serving all those manufacturers. This is a similar way to say this in a conceptual fashion is the more you produce, the easier it is to get great payback. But as soon as you start to produce below 10 to 20,000 widgets a year, you don't have enough volume to usually absorb the cost of industrial automation the way it is designed and deployed today. Not only obviously you need to pay for the technology, the hardware and the software needed, you also need to pay for the service with the folks that have the expertise to design those systems and eventually deploy it. That leaves a humongous amount of manufacturers outside of the benefit of industrial automation. That's really what we're trying to resolve, right? Most manufacturers today that we speak with are seeking payback at a maximum a year to a year and a half. And the smaller the manufacturer is, the shorter the payback will be seek. We have some high throughput manufacturers that can afford to have a 2 years and a half to 3 years and a half payback, but this is not the majority. And again, if you're not producing that higher level volume, really, really hard to achieve those payback with today's technology. This is one of my good friend, Stephen Gale, is actually, this quote came from him. That was one of our very first client back in 2018. Vention was a year and a half into the adventure. And Stephen was a maintenance technician at a company called Foothill Industry on the East Coast. And they're manufacturing surgical drape, those blue drapes separating patient and hospital. And everything was done manual. And Stephen decided to take the mandate by himself to automate fabric cutting. The machine you see here was done by him, programmed by him. Stephen had all the process expertise needed, but the learning the learning curve of learning all the technology we need prevented us from contributing to that level to his factory plan. So this is was our first data point proving that there's a real benefit to be created here by providing democratized technology to folks like Stephen, that if we equip them with technology that is simple enough, they can do beautiful thing in their own manufacturing plant. So that's a little bit how we see the world at Vention. And what you see here is the platform we've assembled over the years. We have the design stage where we can obviously, our users can bring perhaps file from the known CAD platform or can design from scratch. They can also define their scope with machine scope. A lot of clients that come to us are realizing their first automation project and they don't know all the questions they should ask. And machine scope is one of those software. We help them define their requirement. They can automate with various infrastructure we've provided for machine logic or machine code when you work in programmatics, or perhaps using some of the apps from the libraries for palletizing, sending, and others. All those infrastructures are obviously compatible with some leading brands. Some of our partners like Fennec and Universal Robot that we've been working with for multiple years at democratizing the industry. And then you see the rest, and people can order and deploy and obviously operate. That's really the platform we've assembled with the sole mission to serve the Stephen Gale of the world, those users that have tremendous amount of knowledge. And if we equip them with simple technology, they can do beautiful things. That brings me to why we're here today. And I want to talk about the report we've assembled using all the data that we accumulate on the Vention platform to see if the thesis we had when we created Vention was actually coming a reality. For those that are active on Spotify, very couple of weeks ago, all of us got our 2023 Wrapped, right? That report that tells us all the songs that we've listened to and the one that are the most popular. And that very report to me triggered the idea to do our own report about the data we are, accumulating here at Vention to give this portrait to the industry. And this was a pet project of mine for the last couple of years. I'm very excited we assembled this year. And for those that are following me in various trade shows and so on, at Automate next year in May in Chicago, we'll actually be presenting the updated version of this report you're about to discover today. For those that have witnessed some of my talk in previous event this year, you might have seen glimpses of that report. Some of you might have downloaded online. Today, I'm going to try to really storytell all the insight that we've learned by looking at all the projects that our clients have done and how can we inform the path for the industry from here. Okay, so Vention is a beautiful platform because everybody has the same toolkit, the same design software, the same Lego bricks. And as a result, it brings a very level playing field across all industries, user persona, and so on. And you can do very, very, very relevant comparison between application, between industry, between company size as a result of it. So the data we're showing you today, the report we're showing you today comes from roughly all the data we accumulated over 2022. That's around 4,000 industrial automation projects over 25 discrete manufacturing industries, right? Some of them I've mentioned it already, but that's automotive, aerospace, electronics, robotics, industrial distribution, medical devices, construction. There's so many industry represented there. And again, it creates, because everybody has the same tool, it really neutralizes for the inherent behavior in those industries and so on. Okay, so let's jump in. Couple of definitions to set the table. What is do-it-yourself automation? We see do-it-yourself automation as the act of self-designing and deploying automation equipment, whether they're robot cells or an automated machine, using plug-and-play hardware and software. That's how you make it simple. You remove a lot of the inherent technology risk to component integration as a result. We see platforming and various productization of industrial automation solution happening right now in the market as a key enabler for do-it-yourself automation. Some of that productization and that those applications that are more and more productive started to emerge just 2-3 years ago, and we see obviously that trend accelerating. What's very interesting about do-it-yourself automation is it enable more companies to create what I call advanced manufacturing team, right? Advanced manufacturing team for us are teams that are usually lives within a bigger organization that are responsible to drive the automation roadmap. Sometimes it's a single engineer responsible for a single factory. Sometimes we're talking about a large centralized team of 15 to 30 people responsible for multiple plants. What's interesting is at the smaller scales, a lot of those advanced manufacturing team we witnessed this year are actually being formed by people that were already in the factories, that have gained enough process knowledge over the years, and because they have access to simple tool, they can start to play a different role. That's the example of Stephen Gale that I've shared with at the beginning of the presentation today. So those team of advanced manufacturing team now, because there's so little technology risk when you using productized automation, can really focus at their deepening their process expertise to make sure their plant runs smoother. So those are a couple of definitions. The way I'd like to represent this is, when I was a young system integrator myself, most companies decided to take on industrial automation project by themselves was only for very simple use cases where both the technology risk and the process risk that characterize industrial automation project was low. I think that's what the benefit of having platforming and productization of industrial automation is bringing, is you can push that frontiers. So those advanced manufacturing team can now take a bigger scope, because they don't have to worry that the integration of the component itself will be difficult. this has been resolved by default by the platform operator like Vention. To me, this basically brings a very natural handshake with system integrators that have deep expertise, because there will always be some process where deep process expertise cannot be developed solely by one team. And that's where system integrators have a big role to play. So that creates that natural handshake where those advanced manufacturing team can now play to a wider spectrums of project, where technology risk can now be higher because it's reduced at their source by the platform. And obviously, as more and more process expertise is needed, system integrator obviously have a strong role to play. So with that framework of what is do-it-yourself automation, what is advanced manufacturing team, and how we think about process risk and technology risk, let's deep dive into the result that we got. The first thing we've learned when we started to peel the onion around those 4,000 projects that was realized in 2023 was who was conducting those projects. And we look obviously at company size. And it turned out that all the clients that have adopted platforming of automations are mostly small, medium business. That was our initial hypothesis, so it's kind of comforting to see that that thesis was true. But interestingly, we still saw a big chunk of enterprise clients that were interested, not for the final assembly line, not for those high throughput assembly line, but perhaps for the second tier or third tier assembly line where the throughput are not as high. The metrology department, for example, in the car manufacturers, the R&D department, perhaps in the battery manufacturers, where again the throughput is not as high, and yet the benefit of speed that can be and simplicity that can be provided by this integrated workflow yields some benefit. If you look at who adopted there's a wide range. In fact, the biggest bucket is others, and that characterized the 25 discrete manufacturing industries we're able to serve. But we saw a lot of adoption in industrial components, in academia and research, in robotic and automation, interestingly in software provider, and electronic device manufacturers. But the very long story is users of platforms represent very closely the fabric of the American GDP, of manufacturing GDP. So equipped with that demographic now, let's look at how often are they realizing project. And again, we're broken that down by enterprise size. But what we notice here, if you look at the chart on the left, is enterprise client, which usually use platform a little bit less. They're high throughput and therefore can afford traditional industrial automation technology, are still big users. They're less, as a whole, they use platform less, but when they decide to use it, they use it more frequently, right? That means an enterprise client could realize on average 4.1 project per year. It's not that far off than small, medium businesses that are still realizing 2.8, 2.6 industrial automation project per year. That's not negligible if you think about how fast we need to adopt or automate all those factories that we saw in one of the map at the beginning. This is probably my favorite insight. How self-serve are those projects can really be, right? Creating automated equipment in robot cell is not simple. You still need to validate reach, you need to validate cycle time, you need to validate safety. There's a lot of items to consider to do a project well. And we wanted to know who can really become self-serve, right? Are the tool easy enough now for users that are just starting to develop their expertise to do a humongous amount of work by themselves? So we'll look at all the project and we'll look at how much of the work was actually done by the user themselves, the client themselves, versus external support they might have gotten perhaps from our application engineers. And I was proud to see that mediums and small businesses are the ones that are the most self-serve, right? They want to learn. They want to upskill their staff. They want to be able to conduct those projects with a different risk and cost profile because the technology is now simple enough. Enterprise on the other end start to be on the lower side of how much self-serve those projects can really be. I'm very interested to see how far we can push that. To me, some things tell me the upper limit will probably hover around 60 to 65%, right? Not all projects will be done self-serve. Some, as we said before, needs tremendous amount of deep process expertise that will be very, very hard for a newcomer to develop by himself. Here, we're trying to look at the speed of project realization. And that's the beauty of having a platform to monitor all that is we can track from the moment somebody starts a machine to the moment that it's deployed, how much time was elapsed. And we can start to categorize perhaps industry here. So we decided to peg the fastest to an index of 100. And everybody else is ranked versus that fastest industry. So the big surprise here, electronic contract manufacturers are the fastest. And it's not a surprise in itself. What we've learned over the years looking at that data in several ways is when you're in an industry where the product life cycle is short, you value time. And therefore, having that end-to-end integration in one platform where you can go from ideation to delivery and commissioning very, very quickly has more value. Electronic contract manufacturers sometimes will have a single order contract, right, for 1,000 units, and then it's over. Sometimes it's 6 months, sometimes it's 9 months. But product obsolescence in electronics is usually within a year. Product change quite quickly. Those folks value time. You can contrast that perhaps with aerospace, where the shelf life of an aircraft is around 25 years. Usually the folks that start the aircraft program are not the same one that will see its obsolescence. It's generation of engineers that will go through the whole aircraft program. And as a result, the sense of urgency or the sense of speed in those industries tend to be lower. And we see that through the data when we give the same tool to everyone. So that's interesting because we can start to look at which industry will likely adopt industrial automation faster than other. And obviously, throughput has a big role to play. Sorry. Throughput has a big role to play in the industry, but also life cycle of that industry, of the product manufacturing that industry has a big role to play as well. Now we ask ourselves, what are people doing with those platforms? What type of project are people interested to do? So we've bucketed that in 3 buckets, right? Structural, which are non-automated equipment. They can be around the automated equipment. I would see lean manufacturing equipment, workstation, cart, jigs and fixtures. They're all structural for us. We have the automated equipment, which are usually do not include a robot arm. They can be Cartesian or gantry robot. They can be a timing belt conveyor or middle assembly line that are automated, can be path following machines and others. And finally, obviously, we have the robot cells, and there's a few examples there. So we ask for each of those buckets, what are people seek to automate using platform? Well, here's the result. Let's start with structural. And it's no surprise that most equipment being done are entirely custom. They're unique. They don't exist in a catalog. The reason there's so many unique project out there is simply because the manufactured good of those clients is very often unique and their manufacturing strategy is unique. And as a result, you end up with unique equipment. The other thing they've done after that, you have robot and pedestal, obviously workstation, a lot of jigs and fixtures, but those are all type of project that clients start to feel comfortable doing by themselves, right? You're giving the right tools and simplistic enough workflows, they're able to go online and design those equipment by themselves. Let's move to the world of automation now. So what are people seeking? And the first one on the very top is a range extender or robot 7-axis that do not include the robot arm. And that's interesting because usually that's a way for a client to do machine tending. They will perhaps do machine tending between one or multiple CNCs or injection molding machine, and they want to save perhaps on the automation project by buying a range extender and a single robot as opposed to 2 robots in front of each machine. This is very, very popular application. Custom equipment, again, is right up there as we look at before. People have unique manufacturing strategy, unique manufacture good, and as a result, need unique manufacturing equipment. Gantry robot, conveyor line, automated jigs, for example, we see that more and more where people want to put jigs that are smart, that can perhaps even talk to the robot that is helping them. So we see those applications bubbling up as part of the application that are automated being done on platform like Vention. And last but not least, automated with robot. And what we see here is machine tending is by far one of the biggest applications that users are trying to do by themselves, right? Followed by a cobot palletizer and custom robot cell again. Machine tending to me is one of the most untapped opportunity, in a sense that everybody has that problems in every discrete manufacturing floor. Machine tending has to be solved. It's just highly complex because every machine needs to be interfaced in a different way. And as a result, you need usually technology specific knowledge of the previous controllers that is already on that legacy equipment to be able to successfully complete your machine tending project. But there's tremendous potential to solve machine tending with a quick ROI, usually below 1 year, using today's technology. Before we wrap up, and I hope so far you found this interesting, and that was our version 1 of that report, and I know that the 2023 report will have even more insight. But I want to share a couple of case study, clients that have embraced the journey of do-it-yourself automation with their advanced manufacturing team and the type of result they were able to achieve as a result. And then I'll wrap us up by just sharing lessons learned from watching those teams being formed at our various clients and how they go about making them successful. This is a case of very interesting company. This is a very large outdoor power equipment manufacturers. And outdoor power equipment manufacturers usually have a deep or a large amount of components that are welded assembly, right? Sheet metal being bent, welded, clean, and paint, right? And welding is a core component of those operations. This company had to launch an entire new product line to comply to a new regulation. Some of those equipment needs to turn electric from gasoline, and as a result, they had to retool welding line. And they decided to use that new products to go from manual to automated using cobot. The team looked at various solutions to do that and decided actually to leverage their advanced manufacturing team. At the time, there was a single person heading the advanced manufacturing team. By the time this project was completed, this entire line was completed, the team is now 6 individuals. And in the business case they've done initially, they look at various ways and they realized that by going platform for this, they could usually navigate from ideation to delivery 3 times faster at roughly 50% of the cost, mostly because the man-hour component in this project was greatly reduced. This client decided to do 1 unit first, prove the business case, and then they scaled to a total of 10 units doing various jobs. For them, the benefit was really around cost reduction here and time to go to market. So this is the case of a 7-axis plus a FANUC cobot and a welding, MIG welding, doing a frame for a power outdoor equipment. Again, teams of 6 that are now doing those projects. And this is a great case of where you don't need too much deep process expertise, yet it's not trivial enough that you still need to put some engineering time to it. This is the right balance and a great example of the frontiers of advanced manufacturing team being pushed as a result of platforming. Now, I think this year, this is the discussion I had myself with the most client around how do I get started? Should I have an advanced manufacturing team or not? And we witnessed a couple of insights from watching all of our clients and having those discussions. For anyone considering perhaps starting an advanced manufacturing team, step number 1 is to have a true technical champion that has a very high technical bar and that will know all the trade needed. And by that, I mean mechanical design, talk about PLC programming. I also talk about robot programming, right? Those to us are the 3 skill set needed in a single individual that can perhaps head that team, and we hire from there. The second step is obviously then bring that diverse expertise, somebody that can do maybe more dedicated to mechanical, somebody that can be dedicated to control, and somebody that can be dedicated to robot programming. But we always saw those teams being successful or starting with someone who has it all, has the 3 skills in a single person. A lot of cases, those initial technical champion that I just described are actually former system integrators that want to work on a product on a consistent basis as a result. The challenge of having those teams is to demonstrate ROI to management fairly quickly. And we always encourage clients to start with a low-risk project that can be a quick win and be perceived in the organization as a quick win. That's the best way to bring management along, foster a healthy dialogue about automation, get acceptance from the operator on the line at the same time. And that first success usually will open the door for more project forward. What we saw sometimes is the first project being done is overly complex for a team that is just being formed. And if the project does not translate to a success, management's appetite to conduct the next project is being greatly diminished. So on the risk return profile, we usually try to optimize for the first project to be on the simpler side. Obviously, getting management buy-in is quite important. Um, Bringing management along, make sure they understand the risk and how we're going to spend the time is quite important. So there's no surprise being done at the end, right? The first project will take more time than the subsequent one. The first time that you get familiar with the specific robot brand, perhaps, or get familiar with the specific manufacturing process, there's tricks of the trade to be learned, and bringing management along is quite important. Last but not least, I will really emphasize to use what I call productized automation or platforming, and it really, really helped just reducing the technical risk of the project so the team can really focus instead on the process risk. It's going to likely increase the chance of success and make everybody, including management, follow along. We've seen this year probably 20 to 50 team like this being formed within our client that we had a chance to witness more closely. And every single time, those rules led to success. So hopefully you find this interesting. You saw that, it convinced you that there's a world for do-it-yourself automation to start to play a bigger role for the entry level to intermediate complexity and simplicity project. Perhaps if you're a manufacturer and you're wondering if you should start an advanced manufacturing team, it also gave you confidence that a lot of other manufacturers are doing it and are successful doing it as well. That's what I had for today. Thank you so much for being with me today and listening to those trends that we see from our side. With that, I'll move to a couple of questions, perhaps, and I'm happy to answer all of those you guys might have come up with.
Perfect. Thank you so much, Etienne, for the great presentation. We will move forward with the Q&A with the 8 minutes we have left. So if you haven't had the chance to submit your question during the webinar, please do it now in the next 5 minutes, and we should be able to go through them. So the first question that was submitted during the webinar, Etienne, is what qualities do you think a team needs to develop an internal manufacturing team and specialities they should have?
I'll reiterate what I talk about technical champion here, but it's really important that the champion or the head of that team has it all to start, right? As the team mature, we can have more separation of expertise, but the as it all to me is often somebody who perhaps did his school as part of a system integrator and learned the trade there, understand again the tree scale mechanical design of those automated equipment and robot cell, understand the control aspect, and understand the robot programming aspect. Usually when you have those 3 core skill set, plus you're able to influence management and bring management along those projects, so you have support from the top, usually you're well set up for success. Again, with all the team we followed this year doing that, this is to me one of the most critical aspect is bring somebody who's technical enough. He will choose the right vendor to work with, he will choose the right technology, will use the right architecture for the automated equipment robot cells to de-risk as much as possible from a design perspective early on and so on. So there's tremendous benefit of starting this way.
Awesome. Thank you so much for that answer. We have another question that came in. The question is, what are some of the common mistakes for those attempting automation for the first time?
That's a good one. So it's always trying to do it too big, too quickly, right? Start with the first robot. Start with the first robot cell. Do that first robot cell, demonstrate that the process you're trying to automate has been successful, and scale from there. We saw too often teams that are just realizing their first automation project doing automated equipment that have 7 or 8 steps. Right? It's a lot to handle when this is your first project. Try to stick with automated equipment or robot cell that has 2 to 3 steps, right, to automate. Maybe you grab the part, you flip it, you do a processing operation, you dispose of it. Like something fairly simple that the team will be for sure successful. The goal of that first robot cell is not only to automate the process and get the ROI, but it's also to get management buy-in. And don't estimate the last point. That's really the one you need.
Perfect. Thank you for that answer. Another question that came in is, what is the size of the team required?
Mhm. We saw various size. To be the one that we saw the most usually is one very strong. We serve a lot of small, medium manufacturers, right? So put my answer in that context. But we saw, a lot of team form of one person that is highly technical, and a perhaps second in command, very often a mechanical designer. So the head of the team will be somebody very strong in control and robotics. Perhaps the second member of the team will be as somebody with strong mechanical design skill. That would be for companies where the manufacturing floor has around 100 employees or so. We saw that. So two FTEs related to automation as a whole, driving their automation roadmap, right? So not only those teams will keep the roadmap up to date and prioritize the various projects against one another. As they finish one project, they take the next one on the pile that has the highest ROI. Now, we start to scale to companies above, let's say, $1 billion revenue, and we serve a few. Those usually will have a team of 15 to 20 people. That's usually what we saw in terms of scale. And those teams obviously are have way more specialized knowledge. So every team member on that team will own a portion, whether it's control, whether it's deployment, whether it's assembly, but they're obviously much more, bigger team.
Perfect. So we will have time for 2 more questions. So if you have not yet submitted your question, or if your question does not have time to be answered, we will follow up with you via email. So one question that came in is, with the reshoring discussion in North America, will companies start investing heavily in internal manufacturing teams?
Yeah. So if you look at the amount of robot shipped in the United States in 2023, or the industry, I think, from the last data from A3 is significantly down versus the peak we had in 2022. It's around 30% less robot arm that were deployed this year versus last year. That said, I've never had to talk about setting up advanced manufacturing with my client as much as I did in 2023. So we see that trend being very, very profound. And despite some of the a little bit pause that we saw in robotic adoption this year in the industry, the topic of adopting do-it-yourself automation and building their own advanced manufacturing team to me has never been as popular as we saw in 2023.
Perfect. Thank you for that answer. And one last question that just came in, we will finish off with that one. So as a mechanical project manager who is more familiar with mechanical design, is it possible to acquire the necessary technical skills in PLC programming and robot automation, especially with the DIY availability, in order to be a technical reference for the AMT?
I absolutely believe so. I absolutely believe so. The answer to me will be in the nuance of what is the first project you're willing to take on. And today, programming a robot can be learned, the basic, roughly 2 to 3 hours. If you were to use a platform to conduct your project, you can also get help, right? There's buttons to perhaps request help from application engineers that will guide you, right? There's help you can get also during the deployment. And after conducting one successful project, perhaps a low complexity or medium complexity project, you will be able to take the next one. The technology is to a point now that it's simple enough that within a day of design, a day of programming, perhaps a couple of days of deployment, and a couple more days to ramp up production, you can be successful. We've witnessed this over and over again. I think, for example, the center behind me is an example. This year we had to train probably of all the visitors we had in VXC, half of them were training on learning how to program various robot brand, for example, learning how to program controllers, to your question that goes beyond the mechanical. So absolutely possible. My guideline would be the same. Start with a project where we can truly be successful. And if you're not sure, reach out and we'll be able to share our insider knowledge around what is reasonable, where's the risk in your project, and what can be done successfully.
Perfect. Thank you for that answer, Etienne, and thank you everyone for all of your questions. That's all the time we have to answer questions. So everybody on the webinar will receive a follow-up email with a link to watch it on demand. So feel free to share it with some colleagues that might be interested. We will also share with you the link to download the full report on the state of automation for 2023. So without further ado, thank you so much, Etienne, and thank you everyone on the webinar.
Thank you, everyone, and have a good winter break. Looking forward to see you all in 2024.